So I just had it happen. I had one of my technicians out at a site cleaning up some cabling. Actually, I was very proud of him. I want to show you what he did. I grabbed some pictures that he emailed me just a couple days ago. He went in to this. This was one of the customers that we manage, and this was their network. And I gave him one mission for the day. I said, "Hey, you need to you need to make that look pretty." And so in the end, this was his end result. I was like, wow, this is like a Jenny Craig commercial. Perfect. It's before and after. This is great. So here's our before and after picture. So anyway, he goes out there. I love looking at that. I love clean cable racks. That's what that is. So anyway, he goes out there and he's doing. I know he's doing this, and I get a call midday. And he goes, Jeremy, I'm freaking out. And I was like, what? What's wrong? What's going on? He's like, everything is down. Everything is down. And I was like, well, hang on, regroup. I said, the monitoring system is showing from the outside. You're still up. It's still online. What's going on? He's like, nobody can connect it. He's panicking. And I go, well, okay, what were you doing? He's like, what you told me to do, cleaning up the rack. He's like, making everything look pretty. And he's like, I was just plugging these things in, and next thing I know, I get somebody banging on the IT room saying everything's down, and so I immediately, as soon as my mind heard that, I was like, he's caused a loop. There's a loop somewhere in the network, and I said, I said his name. I'm not gonna share. Don't want to throw him under the bus, but I said, we'll call him Mike. I said, hey, Mike, what were you plugging in? And he's like, dude, I don't even know what I've plugged in. He said, I've been cleaning this. He's like, I just started clicking stuff in. I don't even know what's there. And I said, you got to backtrack. I said, you got to start going one by one. I said, look at the switches right now. They're probably going crazy, right? And he's like, what do you mean crazy? And I said, lights blinking everywhere. And he goes, yeah. He's like, they are. It's blinking like crazy. And I said, okay, here's what you do. I was like, you start backtracking, start unplugging one by one. He goes, okay. Hey, he goes, hang on. He's like, I'm staying on the phone with you. Let's do this. And he goes, I plugged this in. Nope. He goes, nope. He goes, whoa. He goes, hang on. And he plugged it in again. He goes, this is it. Yeah, I'm plugged in. He goes, this is it. And I could feel him just being like, this is it. And I go, where's that going to? And the irony of it, he followed. I've got these little pictures right here, but I gotta be careful what I'm showing. Anyway, this is a way before picture of it. He pretty much, this was what he was playing in. You see that little guy right there? He's like, yeah, it's like a little 3-inch cable that connects. I'm like, that's the one. I'm like, you're causing a loop in the network. What's going on there? So that's what I'm here. I know it's a long introduction. Forgive me, but it's just interesting that I just went through this a couple days ago, that now I'm talking to you about spanning tree, rapid spanning tree, and kind of what we're going to be thinking of with our design for our branch office. In my experience with the Cisco world, I've found that spanning tree is one of the most unknown, misunderstood kind of topics that's out there. Like, there's not that many people that really get it, because it does out of the box just work. It does its thing. It may be not the most effectively, but I'll say rightly so. It's even for me, when I first got started, I got to share a quick story. When I first got into Cisco, I had already been teaching Microsoft and Novell for many years, and to be a Microsoft trainer, I had to send in a piece of paper that said, I want to be a Microsoft trainer, attached with a check for like $150. And they said, okay, you're a Microsoft trainer. And I'm serious, that was it. When it came to Cisco, and I moved into Cisco, I went to a company back then called KnowledgeNet. They're no longer around. But Cisco actually made me fly out to San Jose and get in front of a whole group of people and do presentations. When I flew out there to become a Cisco certified system instructor, this is back in 2000, I had to fly out there and I had to teach a section from CCNA that I had prepared, and I chose the OSI model. I love talking about the OSI model. It's fun. So I was like, oh, I'm gonna teach that. And then the second part of the day, they actually pick a section, and I'm talking Cisco, picks a section at random from the CCNA material, and then you have 10 minutes to prepare, and then you have to teach 15 minutes of that section to them to their liking. Well, I'll just tell you the results. OSI, I did phenomenal on. I was like, yeah, I know I nailed that. I did great. You know, people were laughing. It was just a great presentation. And then it came to the second presentation. You know where I'm going with this, right? A second presentation. I'm thinking in my mind, please don't pick spanning tree. That's the one topic I just don't get. I just don't get it. This root bridge, designated ports. I don't get it. And sure enough, he's like, and Jeremy, you've got spanning tree. Oh, you feel that cool trickle go down the side of your head. And I'm like, oh no. And I'm sitting there, I'm looking at the same pages I looked at in the plane flight over, going, okay, and I've got 10 minutes, right? And I got up there and did the most, this is where God got involved. I'm like, Lord, if you want me to be a Cisco instructor, and I went up there. At the end of the day, he gave the results. And OSI, sure enough, I got great ratings on. He's like, you did great. The spanning tree, he gave me the lowest possible rating that I could get without failing. Literally, if you want to know, you're like, Jeremy, how'd you become a Cisco instructor? By the grace of God, I scraped by, like barely. Like if I would have gotten one mark lower, that's how bad it was. So I know spanning tree. I say that just because I know many of you listening to me are like, I just don't get spanning tree. So let's talk about it. This is a basic collapse core environment, right? This is, I would say, right next to the smallest model Cisco supports. If you look at what model Cisco has design guides for, the smallest model they support is one multi-layer switch connected to a couple access layer switches. Kind of looks familiar, right? Kind of like our design for our branch office. That's the smallest design Cisco supports. One step up is adding redundancy. And as a matter of fact, this is so timely. Yesterday afternoon, I was at a client, and he's like, Jeremy, I just want you to come out and give me a good design for our new office. We're moving in a brand new, it's a beautiful building. We went to the whiteboard. I want to show you our whiteboard discussion. Really simple network, very similar to the branch office. That's why I'm actually using this model. He's got a new office. This is his office right here. Actually, this whole thing is his office. He's got a 10 meg fiber optic drop. That's his internet connection into the DMARC. So where the service provider ends, it's its own little IDF. That is patched over via fiber to, I wrote IDF, but I was wrong. It was their MDF, their main MDF facility, which then hits a converter, connects to an ASA, that's a little ASA, and that links into what I called their core switch. Now, they're using it's actually Netgear. And I'll tell you, if you deal with Netgear switches, you come to appreciate Cisco. So he's got a couple Netgear, he's got one Netgear switch right here. And I go, okay, and I call him Mike again. Mike, this is going to be easy. All we've got to do, we've got a trunk over here to an IDF for one portion of his building, about 70 users over there. Another trunk coming down here, about 100 users down to this section. We've got VLANs going across. He wanted public Wi-Fi. Very similar to what we're designing for our branch office. And he goes, well, he's like, I said, yep, should be pretty straightforward. He goes, well, any other suggestions? I said, if I can make one, I said, you have no redundancy. I said, you've got a core switch, a little Netgear gig switch, one ASA. He goes, well, show me what it would look like if it were redundant. I go, okay, here it is. I was like, this is it. I drew his internet connection. I said, you get a second ASA. That's all you need. Second ASA and a second core switch. I was like, buy another Netgear switch. That's fine. And you get two core switches. You've already got redundant fiber run to the two IDFs over here. You run that redundantly now to your two core, your two ASAs. Now you've eliminated your single points of failure in the network. And I go, it's just one more ASA and one more core switch. He's like, okay. He's like, well, thank you. I'll keep that in mind for when we have budgets. And right there, it was funny. As I was driving away, I made up my mind. I'm not being nice anymore. Almost all the time. Don't take this the wrong way, but all the time I draw these network diagrams based on what they've got, right? I'm like, all right, if you want to spend nothing except for my time, here's what you do. You set up your, and I drew this out, and he's like, okay, that looks great. And then I make a suggestion. I go, okay, by the way, if you want redundancy, this is what, well, how many people, I'm thinking of this as I'm driving home, right? I'm like, how many people are going to say, oh yeah, we want redundant? Sure, some maybe, but very few. Everybody's going to say, well, when we get the budget. I'll tell you, nobody's ever going to get the budget. Nobody. They're going to wait till something breaks, and then they're going to go, oh, wow, that's why okay, now we'll add the redundancy. But that's a major pain point. So now this, I'm going to say, I'm going to draw up my design with redundancy. I'm going to say, okay, here's what you need to buy. You need to buy another ASA. You need to buy another core switch. This is the design. This is it. And then wait for them to back me down. They're going to say that's too much. What else can we do? Then I'm going to come down to the top design. I'm just telling you, that's what I'm doing, and that's what I would suggest you do. So this is that environment. This is what I drew up as my secondary. If you have the money, kind of thing, redundancy design, which is awesome because it eliminates any single point of failure. You can lose this core switch, you keep running. You can lose this link, you keep running. I mean, not all at the same time, but you can. Everything is redundant. It keeps running, but let's bring it back to the point at hand. Remember, we're in a design / technical discussion here. But without spanning tree, this destroys the network. All it takes is one broadcast. So you've got a PC attached right here. This guy sends a broadcast. It's going to go out every port except the port it was received on. If you're studying for an exam, it's going to go out those 2 ports. This guy receives it on this port, sends it out all these ports. Well, that would just be an ether channel of 1 port. Down this direction, this guy receives it out this direction. He receives it, sends it out this direction, down this direction, and you get the idea. Before long, you get this broadcast that starts doing this loop-de-loop-de-loop-loop thing and destroys the whole network. Now, spanning tree, you'll find, well, I shouldn't say spanning tree, but loops you'll find build on each other. Like you'll see, your network utilization kind of go up, and then, it usually takes about 1 to 5 minutes depending on your network. A couple more broadcasts get sent, couple more get sent, couple more get sent, and before long, you just have a bajillion broadcasts flooding your network, and it takes the whole thing down. So that's what most people get with spanning tree. They go, okay, well, I got it. That's what spanning tree does. So how does it do it? That's the key. There's a big key in knowing how it does that because that helps optimize your network. Well, it will pick a root bridge in the network. You can see this little key. I said need to be sure to set the root bridge in the network. That's the one thing. I mean, all of spanning tree leads up to this one culmination point. You need to know how to set the root bridge. Because by default, spanning tree will pick the oldest switch in your network as the root bridge. Now, by default, every single switch has this spanning tree priorities, 32.768. That's the same priority on everybody. Everybody's tied by default unless you change something. So spanning tree relies on the MAC address as a tiebreaker. So let's say this guy's MAC address is, just to save me the writing, we'll say FF. This guy's MAC address is FE. This guy's MAC address is DA. This guy's MAC address is AA. Now remember, I'm doing MAC addresses, are 12 characters, and I just don't want to write them. But MAC addresses are hexadecimal. So that's 0 through 9, and then A through F. So F is the highest, right? 0 is the lowest. Now, when they manufacture switches, the oldest switch will be the one with the lowest MAC address because they manufacture starting from the lowest MAC address that they've been assigned, meaning they, as a vendor, Cisco as a vendor, has been assigned, and then they start working their way up. So when they designed spanning tree, they said, well, let's make the oldest one be the root bridge by default. Now, you might sit there and go, well, that seems silly. Why didn't they go the other way? Why didn't they say the newest switch or the highest MAC address would be the root bridge? Well, think it through with me. If we have the MAC address breaking the tie, in this case, this guy would be the oldest. He's the lowest MAC address. AA is lower than FF, is lower than DA, all that kind of stuff. So he's the oldest one in this list. Now, if they change the paradigm and the newest one would get elected, this guy would have become the root bridge. And you're like, well, yeah, Jeremy, that's right. It's good. Well, what happens when someone buys a little, $100 switch down the road and plugs it in over here? Well, if you didn't change the default, then that guy becomes the root bridge. All your network shifts over and starts pointing to him. This little $100 switch that somebody bought from Best Buy, who knows where they got it from. It just happens to run spanning tree, and now it preempts, it becomes the root bridge and takes over your network. That's not good. So while it may seem illogical at first to say, well, the oldest one is the root bridge, it actually has a lot of logic because it keeps the network stable even when newer stuff keeps getting added. So Let's work this through. This guy gets elected as the root bridge, right? So he is the root. All the switches in your network will now find the best way to get to the root. And let's assume, for the sake of this discussion, all these links are 1 gigabit per second. So this guy's going to go, okay, well, I could go this way. No, I'm not going to go. Okay, this is the best way to get to the root. I know, you're like, duh. Right there, that's the best way. Let me grab a thicker pen here. That guy is the best way to, wow. Beefy. So we've got that guy being the best way to get the root. He's going to look, he's going to be like, okay, this guy is the best way to get to the root. He's going to look around and be like, okay, well, I can go this way or I can go this way. Now you might look here and hang on, this pen is a little too beefy. Let's go down a little smaller there. You might say, well, which is it going to choose? Because this way is 1, 2. If they're both gig links, it's going to be same, and this one's going to be the gig link. Well, that's where a little tie-breaking algorithm comes in. It's going to say, okay, both of these paths are the best way to the root, so let's pick the one that has the lowest bridge ID. So this is not only used to pick the root, but it's used to break these kind of ties. So it's going to go, okay, well, it looks like we've got FF and FE. Well, FE is lower. Again, remember, lower, oldest, that's the key, lower MAC address than FF. So I'm going to go this way to reach the root, and I'm going to follow this little path down here to get there. So that's going to be what it ends up doing to find the root bridge. So now they all have what's called their root port. They're all going to say, okay, I know the best way to get to the root bridge. Now let's block everything else that's not a root port. Now you can get into the fact that only one side blocks the link, but I'm telling you, the link is blocked regardless. So this gets blocked, this gets blocked. So I wish I could remove those links, but it's not easy. So our end topology looks like this. We've got one link here. We've got one link here. We've got one link here. No redundancy, no loops. But spanning tree is always looking to make sure your primary paths are staying online. And if one goes down, it will unblock one of those blocked paths. So yeah, problem solved, right? Right. But spanning tree just made your path extremely inefficient through the network. Your core switches are virtually unused here. Everything, you can just feel it. Everything's going here. You got some servers right here. And I know this picture is kind of incomplete because we don't have our devices. But let's say we've got some servers and we've got a device over here that needs to copy something to the server, a big file transfer or something. Well, the path he has to take is his traffic goes up here, down here, and up here to reach that server. Ugh. Because this guy, I mean, what is he? We'll say a 2924 XM, or what was it? Not XM, XL. That's an nice old switch there. He's not running much at all. I mean, his backplane can't handle that much. So he, at best case, becomes a bottleneck. He gets a ton of traffic. All these clients that are down here are now going through here. He gets a ton of traffic going through him. Best case, he's a bottleneck. Worst case, you max him out to where he crashes. He runs out of the ability to switch, and he crashes, reboots. You have another switch that gets elected as the root. And I just grabbed one. That's actually not the root. It would be this guy. But he reboots. Once he's back online, he takes over the root again until he crashes, and then you start this little outage, up-down kind of situation that, well, it pretty much takes down the whole network on little intervals. So that's why spanning tree does work by default. It works well, but you want to make sure you pick the right root bridge. Now I pulled this slide out of the archives. This is actually a slide I used from the original CCNA series many moons ago. And I don't want to go through all this in all its glory. That's what the original series is for. I want to kind of enhance it at this point. And I can run through this list. If you're looking at this is a more accurate picture of how the root bridge does get elected. This guy would be the root bridge because everybody's priority is tied there. And he has the lowest MAC address. So between all of them, he becomes the root. So, everybody finds the best root port, points to him, and this link ends up getting blocked. Now, let me fill in a little of what I was mentioning on the previous slide. The link as a whole doesn't get blocked. Only one side blocks its link. Happens to be the side with the least preferred bridge ID. And by the way, this whole thing together, putting the priority plus the MAC address, they call that the bridge ID. So this guy's the unlucky chap because these guys are going, okay, we got a loop here, we got to block this link. He says, well, I'm going to keep mine forwarding. Mine's going to be a designated port. How about you go ahead and block yours, Fred? And Fred says, well, yep, you've got the better bridge ID, BBBB, that beats me, so I will block my port, effectively disabling the link, and now you've got a loop-free network. I put, this is where the tree fell. That's the tree that blocked the link to keep it from running. So that's kind of what we know about spanning tree, and I really want to emphasize that, again, root, bridge, election, all that, but let me take a moment right here to now emphasize the difference between spanning tree and rapid spanning tree. Spanning tree came out, at the dawn of switches. God said, let there be light. Then he said, let there be switches, and let there be spanning tree. This is like an old protocol that's been around for eons and eons and eons. Well, rapid spanning tree came out fairly recently. I'll say within the last 5-6 years. I don't quote me on that. You might look at the standard itself. But it's, in terms of switches, people don't change out their switches that regularly. So it's a fairly new technology that speeds things up. Here's the big difference. Spanning tree is straight up passive, meaning they all do their election, they pick the root bridge, they go, okay, life is good, we're good to go. All of a sudden, this link fails. Somebody unplugged it. Well, the switch at that point now kind of goes into panic mode. It's like, whoa, what's going on? I've got an issue. I've got a link. It's just down. Okay, all right. We've got to get it back up. Now, all along, this guy's been sending something called BPDUs. That's the little spanning tree language of love down here to this guy, letting him know, hey, I've got a path over here to the root bridge. I'm good. This guy goes, okay, you're good. Okay, let's how about let's go into listening mode. Okay, I'm going to listen for 15 seconds. Okay, let's go into learning mode. I'm going to learn for 15, learn the MAC addresses, listening for BPDUs. It's 30 seconds. It's just sitting there going, okay, I think this is good. I think we're loop free. Okay, 30 seconds later, minimum, I'll say, because there's a little blocking penalty it can put on there too. But 30 seconds later, minimum, it goes, okay, that's a good port. Well, back in the days of the dawn of time when spanning tree came out, a 30-second outage was kind of like, wow, that's it? No big deal there. Well, things have progressed. Things move fast. Life comes at you fast, right? What isn't that a commercial, State Farm, or who knows what? But anyway, everything's moving faster. They couldn't handle it anymore. So what they said is, we need to come out with a new flavor of spanning tree. And I'll just say, this guy is passive. That's what I said. This guy is proactive. I'll put proact. Because what he does is, when there is a link failure, now these two switches perform what's called a sync operation. Meaning, he's always been hearing that the root is available from this path. So he's like, okay, I know there's a backup there. So when this goes down, he hears the BPDU. He immediately says, I'm going to perform a sync with you and remove this block immediately. Shoop, link comes up. We now have restored connectivity. Average failover time moves from 30 seconds down to, drum roll please, 2 seconds. 2 seconds on a rapid spanning tree convergence. Now, some of you might look at that and go, wow, that's amazing. Others might look at that and go, we can't handle that. That's going to throw our databases out of sync. That's going to be, missed transactions. That's going to be voice over IP calls dropping. I mean, it's the frame of mindset. So I would say for the vast majority of the world, this is pretty awesome. For the minority, and I'll say currently the minority, because more and more people are moving to this lightning speed world, they might say that's still not good enough, at which point Cisco would say, well, it's time to redo your network design. Time to buy layer 3 switches everywhere and get rid of spanning tree completely on everything except for the edge ports connecting to your NPCs. That's what I would call a next generation design. Well, it's been out for a few years, but that's, a lot of people can't afford to go that direction currently. So to move that direction, that's moving into CCNP. So take all of that as a precursor to get to this point. Spanning tree, as it applies to our branch office, should be fairly simple. The reason I say that is there's no loops in our network. Now, I know some of you might see those dual links right there and go, well, is that a loop? Kind of, but not really. Those dual links are going to be configured with an ether channel, meaning bundled together. So I would say yes, if I didn't have those as an ether channel, that would be a redundant loop, and we would have spanning tree stepping onto the scene to block some of those links. But when we set up an ether channel between those, the switch no longer sees two links. We pull one of our Star Wars moves on it and we go, there's only one link, as we wave our hand in front of the switch. And the switch says, okay, because I'm going to have this virtual port channel, which you're going to see in the next nugget, or maybe in a couple. We're going to start getting into the config of this. We've got these virtual port channel interfaces that treat these and act as though they are one link while load balancing between the two. What I would say as it relates to our design here, and the reason I'm bringing all this spanning tree material into this, is this guy, and only this guy, should be set as the root bridge. It is going to be the core of our network. Everything is connecting to it. And now you might say, well, is it really relevant in this scenario? I would say, yeah, absolutely. Because if we forget, if we don't set the root bridge from the beginning, this network is going to grow. We're going to add more switches here. We're going to start tying them back to this. And at some point, we may end up adding that redundant core. We may end up adding a link like this where we now have a redundant path. And as soon as that redundant link comes in, we now have an issue where if this guy gets picked as the root, or if this guy gets picked as the root, everybody's going to start going through him and using him as the core of the network, similar to what I was designing at the beginning. So even though at this point there is no loops that we have to solve, it would be best to flag that guy as the root just for the future as this network grows. So I'm going to go over to our planning spreadsheet, which is going to start playing huge in the next nugget. And that's going to be configure NLB1S1, this guy, as the STP root bridge. Second thing I want to do, configure all switches to support rapid spanning tree. Because I don't know about you, but 2 seconds sounds a lot better than 30 to me anytime there's a network failure. So with all that, we have now seen, we have looked at VLANs and spanning tree, looking at designing our architecture for VLANs, setting up spanning tree, understanding how spanning tree is going to affect our infrastructure. Now I think we're ready to go. Let's jump into the configuration of these switches. I hope this has been informative for you, and I'd like to thank you for viewing.